just a brief summary of the proceeding without talking about a lot of the details. We start by constructing a graph of the sine function using a reference circle. We then construct a graph of the cosine function by the simple expedient of rotating our coordinate system so that the x-axis points in this direction. We construct then the graph of the cosine function, still starting at the positive x-axis and projecting this x value now, no longer the y value, over to the graph. And we get this graph. Okay, to start here, we get this point. Move here, we get the point corresponding to this, which is here, and so forth. So, we observe that the graph of the cosine function, the graph in yellow, is obtained from the graph of the sine function by simply shifting every point of that graph to the left by distance that corresponds to 1/4 of a complete cycle. And that's a result of simply the fact that we rotated this graph in the positive direction by 1/4 cycle. And it turns out that that gives us values of the cosine that occur 1/4 cycle to the left on our graph. And that's something you really need to work out. And I've asked that you consider proving that the leftward shift of the points on the sine graph corresponding to an arc of 1 quadrant, and that is 1/4 of a cycle. An arc of 1 quadrant is 1/4 of a complete circle, 1/4 of a cycle. And I could actually restate that an arc of 1/4 cycle, that is 1 quadrant, the arc corresponding to 1 quadrant, lands us in the corresponding point of the cosine graph. So we move, and I've indicated that by these blue leftward arrows. Every one of these arrows will land us on a corresponding point of the cosine graph. And that's something you should prove just based on the way this thing's been rotated, and a little bit of actually simple reasoning, but proof at this stage is never simple. So if you don't get it, don't be paranoid, but it's something you should consider proving. Okay, now an alternative construction of the cosine graph then. We don't have to shift this reference circle 90 degrees and construct the graph of the cosine function. We construct the graph of the cosine function just from the graph of the sine function by this 1/4 cycle shift. Now, in order to do that, we do need to extend the graph of the sine function into another cycle. And that's easy to understand. We go around the arc, okay, and these points here correspond, the points from here to here correspond 8 points that take us all the way around the arc. If we continue going around the arc, well, we go another 1/8 of a cycle. So we go a little further to the right, so there is our graph extending. And of course, we can think of moving around this circle repeatedly for an unlimited number of times, which is going to give us an unlimited number of cycles of the sine graph. The sine graph will just keep on going. And the cosine graph can be constructed from that just by shifting every point 1/4 cycle to the left, or even just doing it for 1 cycle and then just repeating this cycle. Okay, and we've talked about the sine function being one of the 3 functions which form a basis for the elementary functions. Okay, so here's how we get the cosine function from that basis. Okay, the sine function gives us the cosine function. It's also, as we're going to see, it gives us cotangent and tangent functions and secant and cosecant functions. We work out the way to notate this relationship. That is, the cosine of theta is going to equal the sine of something else, where theta is just some position along this axis. So if theta is a position along this axis, well, the value of the cosine is, of course, obtained by going up here and over here. Okay, but the cosine isn't one of our basic functions. How do we construct that from one of our three basic functions, our three basis functions for the elementary functions? We do it based on the sine function. So we do assume that we have a completely constructed graph of the sine function. So whatever theta is, we look a quarter of a cycle to our right, find out what the sine value is, and that's going to be our value of our cosine at this point. So cosine of theta, which is just what we get when we project up to the cosine graph and over, has to be equal to the sine at this value along the x-axis, or the horizontal axis. Don't like to talk about x because I've got an x-axis over here. We don't have too many x-axes. Okay, and what's the coordinate of this point where we get the value of the cosine from? If it's the cosine of theta, we've got to look a quarter cycle to the right at theta plus 1/4 cycle, so that when this point is shifted a quarter cycle to the left, it lands on the cosine graph. Okay, so that the value of cosine theta is equal to the value of the sine of theta plus a quarter cycle. And we can write that. Cosine theta equals the sine of theta plus a quarter cycle. Now, usually the argument of the sine or cosine function is either going to be in degrees or radians. In degrees, a quarter of a cycle is a quarter of 360 degrees around the whole circle, which is 90 degrees. If we're in radians, then the whole circle is 2 pi radians, and a quarter of that is pi over 2 radians. So, quarter cycle is either pi over 2 radians or 90 degrees. Now, this does illustrate a general principle that's somewhat counterintuitive, difficult for people to understand. General principle that if we replace x by x plus h, that shifts the graph of whatever our function f of x might be, h units to the left. Okay, you can see it right here. If we replace theta in our sine theta function by theta plus a quarter cycle, we get the values of the cosine function, which is shifted a quarter of a cycle to the left. And that's something you really ought to ponder if you really want to understand graphs and understand this in a way that you'll understand 10 years from now, in a way that's much preferable to memorizing a formula, which is real easy to confuse. Okay, so right there is the rule, but there's the reason for the rule.